Hi, this is Seymour Rocks reporting from down under, and I've got my friend Margo on the other end, and we're just going to talk about how the Arctic looks at the end of the melt season, when it should be refreezing, but doesn't seem to be. So, Margo, take it away. What do you see here?
Well, it's amazing that I can't believe we're already at the end of September, and we didn't have the blue ocean event, they said, but we're having the effects of one. And they said that the minimum was reached around September the 15th, and that there's a little bit of refreeze coming back. But I'm seeing north of the North Pole, it's still really, really disintegrating and breaking up. And, it's coming back just a little skim of ice over in the Beaufort Sea, so that tail is connecting up with the main part of the ice. And I also see the thickest part. It's still moving and shifting and kind of settling in for the winter, because it doesn't really have anywhere to anchor to.
Well, let's just have a look because
Yeah,
this next one sort of shows where the thickest sort of ice is, and
right.
that's how it looks today.
Yeah.
So
Well,
that's not
actually,
exactly that's not a,
it's actually a little bit more to the right of that picture, but
yeah,
yeah,
right.
that's the tail end of it that's coming off of the thickest ice that's mixing down into the Beaufort Sea. So it's still moving. It's still migrating and morphing, and it's a work in progress here.
Well, shall we just go through some of the very sort of basic things that you and I
Sure.
measure, and
Yeah.
we'll just see what we can see. So uh,
Okay. Great.
this is the sea ice concentration. This is the latest that I've got, and
Mm-hmm.
yeah, well, the first thing that I see is a huge hole in the Beaufort Sea, and then
Well,
I don't see any signs of refreeze there.
well, it's refreezing back around the hole. There had been a tail, and then you see the piece, uh, the white area and then the black area in between. It's refreezing there
Yeah, yeah,
in between those two. So it's like the tail is connecting with this main part that's coming out. Can you see my pointer or not?
sorry.
Probably not, because we're
No,
sharing
no,
your
there's no
screen.
pointer there. But
Okay,
anyway,
that's okay.
yeah. So I'll go on to the
And
next.
it's coming back a little bit around the edges, and in the tributaries, it's just very slightly starting to refreeze in the
Yeah, right.
tributaries there. So it's going to take a while for it to go out much further, because the sea ice is so, I mean, the sea surface is so warm. It's going to take time for that sea surface temperature to calm down for it
Yeah.
to refreeze at all.
I really quite like this sea ice concentration map because it just shows the huge area where there's no ice at
Mm-hmm.
all. You know, all that area between
Mm-hmm.
eastern Siberia and where the ice is. I mean, it's a huge
Yeah.
area.
We're not used to seeing that. It's a
No.
different pattern. It's a different pattern this year,
Yeah.
totally. Yeah.
Yeah. Yeah. So let's go on. So this shows I just want to get an idea of kind of what the temperatures are, and these are air temperatures. Um,
Mm-hmm.
so it, what does it show? You know, I mean, it's below zero.
Right. We've got a lot of
You've got this
cold
area
air.
here, which is I don't know what temperature that is. That's higher temperature.
Yeah, that's
Uh,
a little above freezing.
yeah, yeah.
It's in
But
the green. So,
so so, and of course that's what they refer to as the what's happening in
but
the
we
air.
have that warm air. It's swooping down there with you'll see with the 2 meter temperature anomaly, it's swooping down across. So,
Yeah. So this is what the Danish or the Norwegian forecast for the North Pole, -4 degrees
Mm-hmm.
which
That's not very cold,
that's
is
not
it?
very cold. I mean, I'd expect it to be at least
Considering.
-10. I mean, the sun is set, for
Yeah.
God's sake. And
Mm-hmm. In
then,
that part, the sun is set.
so this is a different version. It gives a slightly different temperature, -7.2.
Right.
But that's not exactly overwhelming either, is it?
No,
So now look at this. I mean,
I know.
these are the temperature anomalies. It's
Right.
absolutely incredible. Just
And I think this is from today, so I think the Arctic is up, what, 3.4 C higher than normal?
right.
That's what I saw. And Sam Carana is forecasting it going up, what, 4.3
Mm.
C higher
Yeah,
than normal or something like that.
yeah, yeah.
But we'll see. We'll see what happens.
So here we are. These are the sea surface temperatures.
Mm-hmm.
So I can't actually see what that color means, but it's not.
That's
It's
that's a
above
little
zero,
above
isn't it?
freezing.
Yeah,
It's a little bit above freezing, I think,
yeah.
but right
And of
around the
course,
ice edge.
that's
Yeah.
the sea surface. The sea surface. So
Right,
we'll get to
right,
that in a few minutes, won't we?
right. Yeah,
And this is another thing. I just got this from Earth Null School.
right,
-1.8 degrees at the North Pole.
right. So that's
And
barely cold enough to even freeze anything up
exactly, yeah.
there.
The temperature. I mean, the usual figures minus what -1.8 to even start freezing again. Would that be right? I
Well,
can't.
when it's got the salt water in
Yeah,
it,
yeah, yeah,
it's about that, or
yeah,
2C. It's around 2C, minus 2C,
yeah,
that it starts refreezing, depending
yeah,
on how much salt is in it.
yeah. So these are the sea surface temperature anomalies. I think
Anomalies. Yeah.
I can't see what's on the top right hand corner because
Oh, the
got a pic.
pink, that pink color, that light pink color along that Siberian coastline, that's 6C higher than normal.
Yeah, yeah,
That's the highest.
yeah.
And then like the
So
red
it's
is 5C,
yeah.
all
So
that.
between sort of
So,
about 2 to 6 degrees warmer than normal, isn't it?
right, right. All around the sea ice, it's like that. And that's one reason we have methane coming up in the Barents Sea and the Kara
Yeah.
Sea, because
I'll get to,
there's
I'll
no
get
ice there.
I'll get to the methane because that's a whole different story.
Oh, okay.
So I'm most concerned at the moment with the process of Atlantification,
Right.
and this was put together by someone who did all the wave heights and meters on
Mm-hmm.
Earth Null School, and some of them, it's pretty amazing. I mean, it's hard to see how ice can form when you've got, you know, um, when you've got waves that are 2.4 or 4 meters or 1 meter in height,
Mm-hmm.
and
Yeah.
and I think that's, the the actual air temperatures are only one metric. We've got all these
Right.
other aspects as well. So this is just another
Right.
one, just
Mm-hmm.
showing. I think it must be a different time of the day. I'm really not sure.
Yeah.
So this whole thing. Oh yeah. Well, and then this is the other measurement. It's the one with the
Sea ice
concentration that I
thickness.
always take. The
Yeah.
sea ice thickness.
Right.
It's pretty thin, isn't it?
Yeah. Yeah. It's most of it's in the purple, and then that one part in quadrant 4, I've named them in quadrants. That's where the thickest sea ice
Yeah.
is concentrated and left over. And I was looking back at the last couple of years, and this is a totally different pattern. Last couple of years, the thickest sea ice was right around the coastlines,
Yes.
but this year it pulled away from the coastlines, and now it's kind of moving as a mass, and it's Like
Yeah,
I
so
said, it's trying to anchor on to that Canadian archipelago,
yeah.
but
There's just two
it,
islands there.
yeah, it doesn't have much to hang on to, does it?
No, no, and it hasn't changed that much since when I was looking at this a few weeks ago. Basically, how it looked then is how it looks now.
It's yeah, it was more egg shaped, and it's flattening out more like a rectangle and getting getting thinner up and down and getting wider right and left, kind of.
Yeah, yeah.
So,
But it's still pretty thin at the pole.
and it is still migrating down towards the Beaufort Sea slowly. When you go
Yeah,
through the animation, if you click through it slowly,
I can
which I
I
do,
I can do that. I can do, I think I've got it
then
here. So I'll just
it's you
here we
can
are.
actually see it still moving.
Yeah. Unfortunately, I haven't got the dates on here because I like to
Yeah,
keep the
you like
picture
to
as big
zoom
as
in.
possible.
Yeah.
So, but that's over 30 days. So that's how it's
Right,
changed in
right.
that
Yeah,
time.
it moved from the egg shape out to the rectangle.
Yeah, yeah, yeah,
And
yeah. It's being
a lot
stretched
of that
being
is
stretched out.
a lot of that is from the wave action
Yeah,
and the way that the winds have blown it to, the way the storms have moved everything around.
yeah. Okay, I'll go back to our thing.
Okay.
Okay, so that's the sea ice thickness from the U.S. Navy site. Now this appeared um, just a couple of days ago. Oops, in the Washington Post. I sent it to you. The mixing of planets' ocean waters is
Right.
slowing down, speeding up global warming study finds. So just wondering kind of what you've made of this. I think this is the paper that it relates to seawater generally forms stratified layers with lighter waters near the surface and denser waters at greater depth. The stable configuration acts as a barrier to water mixing that impacts the efficiency of vertical exchanges of heat, carbon, oxygen, and other constituents. Previous quantification of stratification change has been limited to simple differencing of surface and 200-meter depth change and has neglected the spatial complexity of ocean density change, etc., etc. It's a little bit too,
Yeah, it gets pretty technical.
yeah, it's pretty technical. Yeah,
But basically, they're saying that the salinity is, the ocean is changing up in the Arctic because of the way the Atlantic is mixing in and the Pacific is mixing in. And as it becomes more saline or salty, then, it changes the way the whole ecosystem
yeah,
and the way it moves. And in one part of the article, it talks about the AMOC slowing down,
yeah,
which
right.
the which is big trouble for
Mm.
the rest of the planet. It affects all of the climate all over the world.
Yeah, yeah,
And we also have problems because of the ice sheets melting off of Greenland, and that's adding cooler water, and also it's fresh water, it's not salt water, and so it's changing the ecosystem
yeah.
too.
So I presume that I think I even read something about this that the glaciers are melting and they're coming off into the sea, and of course that will be cooling down the area
Hmm.
around Greenland, will it not?
Right, right, yeah. And you can actually see that on when it's not cloudy, you can see it on NASA Worldview where it's
Yeah.
just pouring out
Yes, it's very
on
hard to
Greenland.
find. I mean, I don't think it's been cloudless at the pole for weeks and weeks. You just have to kind of
Oh
find those.
no.
you just have to find these little areas where you can see through the cloud, or there's a little gap or
Yeah.
something. And
There were a few days a couple of weeks ago where there was some good viewing, but recently it's been real cloudy.
it wasn't that bad in the last 2 years that we've been watching it. I mean, it's sort of, I don't think, it's been pretty cloudy up there, but nothing like what we've seen this year.
Well, I think it's because of the warmer temperatures and also the smoke from the fires
Yeah.
has
Well,
been
all of that,
covering things up too.
and of course, the more warming, as they say, the more water vapor you get. So that will
Right.
be,
And they've had a lot of rain up there too, so
yeah.
lots of water coming down.
Anyway, this is another paper that I haven't really had a chance to look at. Reduced efficiency of the Barents Sea cooling machine. So the Barents Sea is where we're seeing huge changes.
Right.
So dense water
That and the
masses.
kerosene, yeah.
Yeah. Dense water masses from the Barents Sea are an important part of the Arctic thermohaline system. Here, using hydrographic observations from 1971 to 2018, we show that the Barents Sea climate system has reached a point where the Barents Sea cooling machine, warmer Atlantic inflow, less sea ice, more regional ocean heat loss, has changed towards less efficient cooling. So, and then there was one other, weakening of the cold Haloclean layer exposes whatever that word, oceanic heat in the eastern Arctic Ocean. So, and well, it's pretty technical, so I don't think I'll read it. But it's just yet another paper that confirms what we already know.
Basically, the bottom line on this one is they're talking about the reduced sea ice cover, allowing the mixing to happen, and then there's no albedo, and so it just stays warm all the time, and so it's just keeps heating up, and
yeah,
it can't cool down, basically.
Which is what you and I have been saying for some time, really.
Right. And the ice did not come back in the Barents Sea last winter. It did not. It came back in the Kara Sea on the east of Novaya Zemlya, but on the west side, it didn't come back at all.
Yeah.
So that has been ice-free completely this whole last year.
Oh, wow. Well, that's huge, isn't it? So,
that's why they're interested in
Svalbard, etc.
Well, Svalbard is getting ice. It gets ice around it.
Yeah.
But it's getting less.
Yeah.
Yeah.
So now we come to the big question about methane. Now, I'm particularly interested in hearing from you about this. I've just chosen this because I just had it on my records. That's going way back to a month ago, and this huge outpouring of methane from near Severnaya Zemlya, and then sort of going up to the pole, and then we've seen huge areas, and this is another day, and that's fairly typical, isn't it, Margo?
Well, it's been spewing up there since January. Remember when cams went down for 10 days in January this year?
Yeah.
And then when they came back up, that was there, and it wasn't there before then. It was spewing up further south. But now it's been spewing up there ever since January, and I think we have a methane crater that's opened up in the seafloor. You saw that article or the paper about that, right?
And that was about the Barents Sea, wasn't it?
Yeah, but they have those craters all the way through, and so I think that a rift is opened up in the seafloor and it's just like continuously releasing, because the red tectonic plate line that separates the North America plate with the Eurasia plate runs right up next to there, and it's a place that has earthquakes pretty regularly. So I think that it makes sense that something could open up there from the plate shifting.
Yeah. Well, I mean, certainly we're seeing an uptick in levels of methane. So I'm just
Oh yeah,
really, well, I'm just so impressed that I think you seem to be the only one who's done this work, and if anyone else has done it, they're not really making it public. So,
yeah. Well,
and it's a pretty incredible graph because it shows here that was the maximum level last year,
right.
which was
October the 12th. That was on October the 12th,
yeah,
and that was, I don't remember, what was it, 1885 or something
yeah,
like
something
that?
like that. So it's between 1880 and 1890 parts per
Yeah,
billion.
yeah.
And now this has to be. I think we probably need to re-explain this. That this is taken. These are global levels, aren't they? And they're taken from an average of the METOP 1 and METOP 2 satellite
Right,
data
right. From NOAA,
from
yeah.
NOAA.
From the NOAA methane, yeah.
Because
And
if you,
this is just one level. It's the 477/469 millibar reading. So it's about 500 millibars. So when you're looking at cams, it would relate to about the 500 millibar reading.
yeah, because what most people do is they just paint, they post the latest data from METOP 1 or METOP 2, and then they say, "Oh, this is a high level," but it's very hard to get the trends.
Well, I'm glad I started doing this, and once I got into it, and then I started tracking it daily this year because it started zipping up in February, and that was really too early to see it really going up so fast. But
Yeah,
so I track it daily now too, and then do the weekly reports. But we're up past 1900.
yeah, because I
We're
can't quite see
past
the
that.
figures clear enough to see at what point we exceeded that, that maximum level. It looks as though it was back in, oh God,
Oh, it was
May or
in,
something.
I think it was June.
June, yeah,
Um,
yeah. And we're already at 1900 parts per billion.
1903, yeah,
So,
1903 is where we are right
yeah.
now, or right about.
So that says a
And
lot.
we're not at the end of the rise. It usually methane goes up until about mid-October. That's from all of the heating from the summer in the northern hemisphere, and then it starts going down
Yeah,
until December. Well, generally it's not supposed to really start going back up until summertime, but
yeah,
we saw last year it started zipping up or this year it started zipping up in February. Last year it started zipping up in March, and so it's really it's going crazy.
yeah. And I remember last winter you were reporting, um, you know, methane coming up through the ice in the middle of winter, and then we
Yeah,
found a paper by Natalia Shakova that confirmed
right,
that observation.
right,
She was saying that was
right,
happening, wasn't she?
right. And it's not hard to see when you look at a couple of different models and put it
Yeah,
together. You can see that it has to be coming up through the ice because there's nowhere else for it to be coming from.
yeah, yeah. So basically, what we're seeing is it's not a blue ocean event as so many people are obsessed with. It's either one thing or the other, and it's not a huge 50 gigaton methane burp, but the trends are just, well, they're unescapable if you want to look.
Right.
So
And
that's,
and the problem is we never go back down lower than, or back down to the lowest of where it was the year before. We always start up higher than where
yeah,
we
yeah.
started the year before. And then
Well, you
we
can
go
see that in
higher and
that
higher and higher.
in the graph. You can see.
So we're in no man's land, you
Yeah,
know.
yeah,
We're in territory we've never been in before, ever,
yeah, yeah.
in human recorded history, not ever. So we don't know what to expect.
No. So I think we've basically reached our conclusion, haven't we? Really? I mean, it's the melt season seems to have ended, but the refreeze, except for sort of superficial layers, that are associated with lower um, air temperatures. Um, there's no refreeze, and basically the reason for that is that we've got this Atlantification, we've got high wave action, and then we've got warm water, under the ice. So
Yeah, it's melting
is that a
underneath the
fair
sea.
enough summary?
I think it's going to be struggling, and I think they might have been premature to go ahead and say they'd reached the minimum, but they count every little crumb and every little
Yeah,
film of ice that you could just run your finger through it. They
yeah.
count that as extent.
Well, the big thing that really showed that to me so clearly is not our observation, from the satellite pictures, but it was those pictures that came back from Mosaic when they actually
Oh
reached the
yeah,
North Pole. I mean, that just when you
that was
when
stunning.
when you see that, and there have been a couple of videos that have come out. I think Reuters did one. It just showed. Well, it showed the Atlantification because it just looked like a normal sea with waves and everything, and
Right.
and and of course there was not very little or no ice. Anyway, it don't look too good. So I think,
No, I
Margo,
think
I'll
it's going to be struggling.
I'll leave it. I'll leave our presentation there. So that's Margo and Seymour Rocks from Down Under.
Thank you. Take care.
Thank you, Margo.
Thank you, Robin.